It's now clear that the Soviet Union has suffered one of the worst disasters in the history of nuclear power. Massive quantities of radiation have apparently been released.
For decades, we've been told that Chernobyl was a wasteland, a frozen ruin where radiation destroyed everything, where the red forest died overnight, and where life was never supposed to return. Scientists believed nothing could survive there, but when researchers placed hidden cameras deep inside the exclusion zone, the footage revealed something no one expected. Animals were coming back, predators were thriving, and in some species, scientists even discovered signs of rapid genetic adaptation. It wasn't a story of silence anymore. It was a story of survival that seemed to defy science itself. To understand how this happened, we need to return to the night of the explosion. The night of the explosion. It began late at night at Reactor 4 in Chernobyl. On April 26, 1986, a safety test was running inside the nuclear plant. The control systems failed. The heat kept rising inside the reactor. Pressure increased faster than anyone expected. Then a sudden blast tore through the building. The roof broke apart. A bright glow filled the sky. Workers heard a deep shock wave move through the ground. Most of them did not understand what had happened, but in that moment, radiation had already begun spreading into the air. Above the city of Pripyat, an invisible cloud drifted silently. Families woke to a strange light near the horizon. Some thought it was only a fire at the plant. Neighbors stood on balconies to watch the smoke. No warning was given. Many people went back to sleep. Children were prepared for school as usual. The danger was already all around them, but no one could see it.
By morning, people began to feel sick. Their skin burned. Their heads felt heavy. Some tasted metal in their mouths. Firefighters arrived at the plant with almost no protective gear. They climbed onto the roof and walked across burning graphite without realizing it was radioactive. They worked through heat, smoke, and confusion, trying to stop the flames. Many of them paid for that bravery with their lives. Soon, buses filled the streets of Pripyat. Authorities announced that residents must leave for a short time. Take your documents, bring only a few things, you will return soon. So people left their homes as they were. Toys stayed on beds, plates stayed on tables, books remained open on school desks. Most believed they would be back within days. They never returned. The city turned silent. Windows cracked. Paint peeled from the walls. The Ferris wheel stood still in the empty park. Near the plant, the pine trees changed color, almost overnight. Needles turned red. The birds disappeared. The forest received a new name, the Red Forest, one of the most contaminated areas on the planet. Chernobyl became more than a disaster site. It became a frozen moment in history where life stopped suddenly and the world was forced to face the cost of one mistake. The explosion had shaken the plant's surface, but a greater threat was still forming deep below the reactor, and the only way to stop it was to send a small group of men into a dark, flooded chamber where almost no one else was willing to go. The mission beneath the reactor. Those men who were sent into the dark, flooded chamber stepped forward because they understood that what waited below the reactor was even more dangerous than what had already happened above it. Under the damaged structure, a large pool of water had collected. It was part of the plant's safety system. Above that pool, melted nuclear fuel was slowly moving downward through the broken concrete. If that molten material came into contact with the water, it could trigger a massive steam blast that could destroy the rest of the plant and spread radiation across many countries. The only way to eliminate this risk was to drain the pool. But the valves that controlled the water were deep inside the flooded space. Machines could not reach them. Remote tools did not work there. The job had to be done by hand. 3 workers agreed to go. Their names were Alexei Ananenko, Valery Bespalov, and Boris Baranov. They knew the danger. They understood the radiation level in that area. Still, they chose to enter because they believed their actions could prevent a far bigger disaster. They put on protective suits. They carried small flashlights to help them see through the dark water. As they walked inside, the water rose to their chests. The space was narrow. The floor was uneven. Pieces of broken metal floated around them. The sound of water echoed through the pipes, guiding them. They moved slowly. They followed the plant layout they were familiar with from their work. They searched along the pipe system until they reached the valve line. When they found the correct valve, they used their tools to open it. The water began to drain. With the pool emptied, the risk of a second explosion dropped sharply. Their mission helped prevent further damage and likely saved millions of lives across Europe.
For many years, people believed these men died soon after the mission. Their story was told as if they had sacrificed themselves and never returned. Later records showed that two of them, Ananenko and Bezalov, lived for decades. Baranov passed away in 2005 from causes that were not directly linked to radiation. This information helped researchers better understand what really happened inside the plant in those early days. Their work did not end the crisis, but it changed the outcome. It bought time. It slowed the danger. It allowed the next group of workers to continue stabilizing the site. Radiation still covered the area. Debris covered the roofs and grounds. Broken graphite and metal fragments lay scattered across the plant. The damaged reactor needed to be sealed, and the surrounding area needed a massive-scale cleanup. And soon thousands more people would arrive. Soldiers, engineers, miners, medics, and civilians. All of them would step into the danger that remained, rebuilding the zone. Those who arrived after the first emergency missions came in large groups, sent because the work at the site was far from over, and the danger still needed careful control. They were later known as the Chernobyl liquidators. Many of them were soldiers, engineers, plant workers, miners, drivers, doctors, and firefighters. Most had regular jobs and everyday lives before this, but they were called because the cleanup needed many hands and many skills. Their work was no longer about rescue. It was about control, order, and safety. The plant grounds were covered with damaged parts and contaminated material, and teams were assigned to particular tasks so that each area could be made safe step by step.
Some workers handled equipment. Others measured radiation. Some waste was transported to special storage areas. Each task was small on its own, but together they helped stabilize the zone. Machines could not clean many areas, so people had to do the work themselves. They followed strict time limits and short work shifts to reduce exposure. Each worker was told how far to walk, where to stand, and when to leave. The instructions were direct because mistakes in those areas could cause serious harm. Even with the limits, the work was tiring, and many workers later said the site felt quiet while they worked. Teams also built new structures around damaged sections of the plant. Large blocks, metal frames, and concrete walls were placed to cover and shield dangerous areas. This helped reduce the amount of radiation that escaped into the air. It also helped protect the workers who still needed to move through the site during later stages of cleanup. The goal was not to erase the damage, but to contain it so that it could be watched and managed. In other parts of the zone, roads were cleared, equipment was moved, and vehicles were used to transport materials away from the most dangerous spots. Medics and monitoring staff checked workers after each shift. Records were kept to enable future studies of health effects. Over time, more groups rotated in, while others returned home once their assignment ended. Across the months that followed, hundreds of thousands of people took part in this effort. Their work did not make the area safe to live in again, but it reduced the long-term impact on surrounding regions and helped protect nearby countries from greater harm.
Later studies confirmed that their actions reduced radiation exposure across much of Europe and altered the scale of the disaster. When the major cleanup work slowed, the zone became still again. Homes remained empty, streets stayed quiet, buildings stood without people inside them. The land was cut off from ordinary life, and human activity almost disappeared from the region. And in that silence, something else slowly began to return. Not through planning or orders, but through nature itself. The cameras in the forest. Those larger animals that had begun moving through the quiet forests piqued scientists' curiosity because people no longer lived in the exclusion zone, and no one really knew how wildlife was using the land after so many years without human activity. The area was large and challenging to study in person, so researchers sought a way to observe it without disturbing the animals or entering dangerous areas. To do this, they set up motion-activated cameras across different parts of the zone. Some cameras were placed in areas with higher radiation levels and others in areas with lower radiation levels. The purpose was simple. They wanted to see which animals were present, how often they appeared, and how they moved through the land. At first, many recordings showed only empty fields, broken buildings, and trees moving in the wind. Days passed with little activity, but new images began to appear slowly. A deer walked through the snow. A fox crossed a road near an abandoned house. A wild boar searched for food near fallen branches.
These small recordings showed that animals were not only passing through the area, they were living there. Over time, the cameras captured many species. There were deer, elk, wild boar, foxes, wolves, and several kinds of birds. Some species had not been seen in that region for many years before the disaster. Others appeared in greater numbers than expected. The recordings help scientists compare where each animal preferred to spend time, whether near empty towns, open fields, or deeper forest areas. The footage also showed animals in places where radiation levels were still higher. This did not mean the environment was safe or that the animals were unaffected, but it showed that wildlife was adapting to the space in its own way. With fewer roads, fewer buildings, and no hunting, the land had changed and animals had slowly filled the open areas left behind. The camera footage provided researchers with valuable insights into how ecosystems behave when people leave a region for many years. It helped them study how animal populations respond when human noise, farming, traffic, and construction disappear. The exclusion zone became an unusual case study because it was a damaged environment free of daily human influence. Here's a simple question to think about. When nature spreads into a place that people can no longer live in, is it only returning to what existed before, or is it creating something new in that environment? As scientists continued studying the recordings, they began to notice important patterns among certain animals, especially the wolves, which now moved across wide parts of the exclusion zone and lived there year after year.
The returning animals, the wolves scientists had been watching through the cameras, were vital because they not only moved across the exclusion zone, but also lived there for many years, showing that they could build stable groups in a place where people no longer lived. The recordings showed adult wolves traveling in packs, young pups following older animals, and tracks spread across snow, fields, and forest paths. Researchers compared these wolves with wolf populations outside the exclusion zone. They noticed that the number of wolves within the zone was higher than expected, even in areas where radiation levels remained in the soil and plants. One reason was that there was no hunting, no farming, and very little human disturbance, which gave the wolves more space, more territory, and more time to raise their young.
Prey animals, such as deer and wild boar, were also common in the area, so there was enough food to support growing packs. The cameras also showed many other animals using the land. There were foxes near buildings, elk in open fields, wild boar in muddy ground, and birds nesting in quiet areas. These recordings helped scientists see that wildlife was not returning in small numbers. Instead, many species were living together again in the same space, forming a fully functional ecosystem. Researchers explained that this did not mean the exclusion zone was safe or risk-free. Radiation was still present in some parts of the environment, and not every species was affected equally. Some animals avoided certain areas, while others stayed inside them. Even with these limits, the long-term recordings showed steady animal activity and repeated breeding over many years.
This led scientists to think about a larger idea. When human activity disappears from a landscape, nature does not simply return to what it was before, but begins shaping the land in its own way, through movement, feeding, nesting, and population growth. The exclusion zone slowly became a rare example of how wildlife behaves when people leave an area almost entirely. As researchers continued studying the wolves that lived there, they began to look not only at their behavior, but also at their biology to see whether long-term life in this environment was changing their bodies in noticeable ways. The DNA changes about the same wolves that had been living in the exclusion zone for many generations. Scientists wanted to look beyond behavior and movement and study what was happening inside their bodies. These animals were born, raised, and aged in a place where radiation remained in the soil and plants. So researchers collected blood and tissue samples to compare them with those of wolves from regions far outside the zone. When the samples were examined, scientists noticed differences in the DNA of Chernobyl wolves. Some of these differences were linked to the immune system, which protects the body against disease and cell damage. The wolves in the zone showed genetic patterns suggesting their bodies uniquely responded to environmental stress. This did not mean they were perfectly healthy or free from risk. It simply showed that their bodies were adjusting over time. Researchers described these findings as signs of adaptation. The wolves were not becoming stronger across the board.
Nor were they resistant to radiation, but their DNA showed traits sometimes seen in animals living in difficult or stressful habitats. Studies on other species, including birds and smaller mammals, also found genetic differences in some populations. Although the effects varied across groups, some changes seemed helpful. Others did not show a clear benefit. A few might cause problems in the long term. The impact depended on where the animals lived, the level of radiation at that location, and how many generations had been exposed to it. This showed that life in the exclusion zone was complex and that the path to recovery was neither simple nor uniform. The research helped scientists understand how wildlife may adapt when human activity is removed, even when environmental pressure persists. The zone became an unusual outdoor laboratory where long-term changes in animals could be observed without direct human interference. Even with these findings, scientists continue to warn that radiation in certain areas remains hazardous and requires ongoing monitoring, especially for people. Yet, alongside these risks, the region now contains active forests, rivers, and wildlife communities that function in their own ways, creating a landscape where damage and renewal coexist and continue to shape the future of the zone. The danger beneath. While the region now has forests and active animal life, the same land still harbors risks from the accident, which is why scientists continue to study it carefully today. Even though wildlife live across much of the exclusion zone, some parts of the soil, trees, and ground materials still contain radiation that has accumulated over many years. Researchers use maps, sensors, and field surveys to measure these areas. Their data show that specific locations near the damaged plant and the red forest have higher radiation levels than the surrounding land. In some of these places, a short visit can expose a person to more radiation than they would typically receive in a year, which is why entry is limited and often requires protective measures. Some contamination comes from pieces of fuel, graphite, and other radioactive materials that settled into the soil after the explosion and cleanup work. Over time, rain, wind, and ground movement can shift these particles, creating new concentrated spots. As a result, radiation levels in the zone do not remain constant across all areas, and monitoring is still necessary. Certain elements in the ground break down very slowly and may remain for decades or longer. This is why experts say the exclusion zone will continue to require long-term observation, restricted access, and careful land use, even though wildlife has adapted to living there. Chernobyl is therefore a place of contrast. It is a damaged environment that still carries danger, but it is also a functioning ecosystem where animals, plants, and forests continue to grow without human settlement. The site shows how life can change when people leave a landscape, while also reminding us how long the effects of a single disaster can last. And as scientists continue to study this region over time, the questions it raises about nature recovery and responsibility remain essential for the future. Even after decades, Chernobyl remains a place of warning and resilience.
Where nature adapts while danger still exists beneath the surface, its story reminds us of the power of our actions in the world we live in. I hope you enjoyed this video. Make sure to give it a thumbs up. Also, consider subscribing to the channel if you haven't already, because we will be uploading more crazy stories like this one in the coming weeks. Until then, see ya. Amazing discoveries. Make sure to subscribe and hit the bell icon. Share this video with friends and join the discussion on what these findings could mean. Your thoughts and questions are important, so let's explore incredible mysteries together.